Dear students, so now we will see example 6. So the question is, a light L is being raised up a pole. See figure 2.4.3. So the figure is given. A light L is being raised up a pole. So this is the light L. It is raised on a pole. The light shines on the object Q. So the light shines on the object Q. So this is the object Q, casting a shadow on the ground. So this is the Q is given here, and it casts a shadow here. It casts a shadow on the ground. At a certain moment, the light is 40 meters off the ground. So at certain moment, we have the light is 40 meters off the ground, rising at 5 meters per minute. Okay, so the rate of change of rising increases 5 meters per minute. How fast is the shadow shrinking at that instant? The question is how fast this shadow. So suppose this is the shadow here, and suppose this is the length of the shadow. So the question is how fast is this shadow shrinking at that time t? Okay. Also, these things are given in the problem. That is, this is 20 meters is given, and this height is 10 meters. It is also given in the problem. So we will suppose that height of the light at time t is y. So this distance we have taken it to be y. Okay. And suppose that length of the shadow is x. So this is a shadow. So suppose this length is x. So Q is the object on which light shines. So it will have a shadow here. And suppose the length of the shadow is x. So we have to find that how fast is the shadow shrinking at that instant. It means that we have to find, if we have taken length of the shadow to be x, so it means that we have to find dx by dt. And it will be negative quantity because it is shrinking. Okay, because the shadow is shrinking. If the shadow is expanding, it will be a positive quantity. So dx by dt will be a negative quantity, which implies that it is shrinking. So also we have given that at a certain moment the light is 40 meters off the ground. So at some time we have this information. At some moment we have y takes the value 40, and at that time when y takes the value 40, the rate of change dy by dt, the rate of change is, since it is rising at 5 meters per minute, so it is positive 5. dy by dt is positive 5 at when y is 40. That is also given in the problem. Okay. So here first of all this triangle we will use the similarity rules for triangles. So here we have two triangles. Suppose I name it like this. So this is 10, this is x, 20, y, like that. Okay. So the full length of AC will be x plus 20. So we know by similarity rules of triangles, we know that the ratios of similar triangles are proportional. That is AE. So this is AE by total length AC will be same as DE by BC, and the ratio is again same to be AD by AB. Okay, so this we have from similar triangles. We will use only the first two. So here AE is x, AC is x plus 20. So we got x by x plus 20 equal to DE is 10. So it is 10. BC is y. So this ratio, this is not required. Okay. So we got x by x plus 20 equal to 10 by y. Now if you multiply it, you will get xy equal to 10 into x plus 20. Mark it as equation number 1. Okay. Now if we differentiate both sides with respect to t, so we are differentiating this both sides with respect to t. So here we have to use the product rule. Okay, so we have d by dt of xy. So it will be x into dy by dt plus y into dx by dt. It is the product rule we have to use. So we have in the LHS x into dy by dt plus y into dx by dt equal to here derivative of 10x plus 20. So we have d by dt of it is 10x plus it is 10 into 20. So derivative of 10 constant can be taken outside into dx by dt. Okay. Plus here it is a constant term, so its derivative is 0. So here we will get 10 dx by dt. So this is the RHS. Okay. Now from this we can write what is dx by dt. So I have taken dx by dt is common. So y minus 10 into x dy by dt I have taken to RHS. So dx by dt into y minus 10 equal to minus x dy by dt. Mark it as equation number 2. Now we have that at certain time we have at certain moment y equal to 40, and at that time we also have that dy by dt is also we have at that time dy by dt is 5. It is given in the problem. So when y takes the value 40. So now we substitute in equation 1. So equation 1 implies in 1 you put y equal to 40. So x becomes 10 by 40 into x plus 20. Now solve for x. So if you solve for x, you will get x equal to 20 by 3. So we got the value of x. Now we substitute the value of x in equation 2. So equation 2 becomes dx by dt into y also we substitute. We have y equal to 40 we have. Okay, that we have substituted here. Y equal 40 minus 10 equal to x we have 20 minus x is 20 by 3 and dy by dt is 5. Okay, so this is the value of dy by dt. That also we have substituted. Now if you simplify this, we will get that dx by dt is minus 10 by 9. So the minus sign indicates that the shadow is shrinking and the rate of shrinking is 10 by 9 meters per minute. Okay, as it is given in the problem. So we got that the shadow is shrinking at 10 by 9 meters per minute. Now we will see another problem. A spherical balloon is being blown up by a child. At a certain instant during inflation, air enters the balloon to make the volume increase at a rate of 50 cubic centimeters a second. At the same instant, the balloon has a radius of 10 centimeter. How fast is the radius changing with time? Okay. So it is given that at certain time we have radius of 10 centimeter, and it is also given that the volume increases. So rate of change of volume increases at a rate of. So at a rate means it is rate of change of volume is dV by dt is given to be 50 cubic centimeters per second. Okay. So it is 50 cubic centimeters per second. Now our aim is to find how fast is the radius changing with time. So our aim is to find dr by dt. How fast is the radius changing? So this is we have to calculate. So we know that volume of the sphere. We know that volume is sphere is given to be 4 by 3 pi r cube. So this is the formula for volume of a sphere, because a balloon will look like a sphere. So it is as it is a spherical balloon. So volume of sphere is 4 by 3 pi r cube, where r is the radius of the sphere. Now if you differentiate this with respect to t, so you differentiate with respect to t, we get LHS become dV by dt. Okay, suppose we denote it by V. So dV by dt equal to 4 by 3 pi is a constant and derivative of r cube is 3 r square dr by dt. Okay. Now from here we will substitute the value dV by dt. In the problem it is given to be 50. 4 by 3 pi 3 will get cancelled. So we have 4 pi r square. R is given to be 10. So it is 10 into 10 dr by dt. So this we can simplify and we will get that dr by dt is 1 by 8 pi. So it is approximately equal to 0.04 centimeter per second. So this is the rate of the increase in the radius change of the radius. Okay. Okay, so thank you.